What if I told you that history could be on the brink of repeating itself, but not in the way we hoped? Picture this: NASA, a new pride and joy, the Boeing Starliner, a spacecraft designed to usher us into a new era of space exploration, is facing ominous warnings from top scientists. They're drawing chilling parallels to the infamous Apollo 13 mission, a mission that came perilously close to catastrophe. Could the Boeing Starliner be heading for the same fate? Today, we dive deep into the heart of these concerns, unraveling the mysteries and potential dangers that could make the Boeing Starliner the next Apollo 13. Buckle up, because this journey into the unknown is just beginning. The story of the Boeing Starliner began with an ambitious goal: to restore the United States' ability to send astronauts to the International Space Station without relying on foreign spacecraft. Developed under NASA, a commercial crew program, the Starliner was meant to be a cutting-edge spacecraft, blending modern technology with tested engineering principles. The project kicked off in 2010, with Boeing aiming to create a versatile vehicle capable of carrying up to 7 astronauts, or a mix of crew and cargo. The spacecraft boasted a sleek, reusable design, aimed at reducing costs over time. Early on, the Starliner faced numerous challenges, including delays and budget overruns. But with perseverance, the team pushed forward, conducting a series of uncrewed test flights. The first significant milestone came in December 2019, when the Starliner embarked on its maiden voyage, the Orbital Flight Test 1. Despite initial excitement, the mission didn't go as planned. The spacecraft encountered software issues that prevented it from docking with the International Space Station. This setback was a stark reminder of the complexities involved in space travel. Undeterred, Boeing and NASA worked tirelessly to address these issues, preparing for the next series of tests. With each step, they moved closer to their goal of a safe, reliable spacecraft. The journey of the Boeing Starliner is a testament to human ingenuity and determination. But as we will see, it has also been fraught with challenges and potential risks that echo the haunting memories of Apollo 13. The second practice involves understanding the key issues and technical problems identified by NASA scientists. One of the primary concerns centers around the spacecraft's software. During the Orbital Flight Test 1, a critical timing error in the mission clock caused the Starliner to miss its planned orbit, preventing it from reaching the International Space Station. This software glitch was alarming, as it indicated deeper systemic issues that could jeopardize the safety of future missions. In a report following the mission, NASA Associate Administrator for Human Exploration and Operations, Doug Lovro, stated, "The software errors exposed gaps in Boeing's testing procedures. These issues must be addressed to ensure the Starliner's reliability and safety." Another significant problem involves the spacecraft's communication systems. The Starliner experienced unexpected signal loss during its maiden flight, complicating commands and telemetry data exchanges between the spacecraft and ground control. This kind of communication breakdown in space can be catastrophic, as it hampers the ability to manage mission-critical operations. NASA engineers highlighted that this problem needs a robust solution to prevent such risks in manned missions. Additionally, there were concerns about the parachute deployment system. During testing, anomalies in the parachute deployment sequence raised alarms, given the vital role parachutes play in the safe return of astronauts to Earth. According to NASA, the Chief of Safety and Mission Assurance, Steve Jurczyk, ensuring the parachutes deploy correctly is non-negotiable. Any failure in this system could lead to tragic outcomes. These technical issues paint a concerning picture, but it is through acknowledging and addressing these problems that Boeing and NASA aim to pave the way for a safer future in space exploration. Drawing parallels between the current situation with the Starliner and the challenges faced during the Apollo 13 mission, we see some eerie resemblances that highlight the potential risks involved. Just like Apollo 13, which suffered a critical in-flight explosion leading to a life-threatening situation, the Starliner faces its own set of daunting technical hurdles. Both missions reveal how even minor oversights in software can escalate into significant threats. The infamous Apollo 13, "Houston, we've had a problem," moment stemmed from a seemingly benign issue that spiraled out of control. Similarly, The Starliner's software glitch during its orbital flight test 1 underscores how fragile space missions can be when software errors expose vulnerabilities. Communication issues were also a concern for both missions. Apollo 13 experienced a communication blackout during re-entry, making it impossible for ground control to receive live telemetry data. The Starliner's signal loss during its flight mirrors this problem, emphasizing the importance of maintaining a robust line of communication. Without reliable communication, the risks to mission success and astronaut safety increase dramatically. Moreover, the parallels extend to the critical nature of the landing systems. Apollo 13 relied on its parachutes for a safe splashdown in the Pacific Ocean, and any failure in this system could have been catastrophic. The Starliner's concerns about parachute deployment anomalies are strikingly similar. Assuring that these parachutes deploy correctly is vital for the safe return of astronauts. Imagine a scenario where the parachutes fail, and we could be faced with a heart-stopping crisis akin to that experienced by Apollo 13 crew. These parallels are not just historical footnotes. They are real, tangible risks that require diligent attention. The lessons learned from Apollo 13 emphasize the importance of rigorous testing, robust communication systems, and reliable landing protocols. By addressing these areas with utmost seriousness, we can hope to avert repeating history in the most unfortunate ways. The steps being taken to address these issues involve an all-hands on-deck approach from both Boeing and NASA, with a substantial focus on rigorous software testing and validation. Engineers have overhauled the testing procedures to include extensive simulations and automated testing environments designed to detect and rectify any potential errors before they can impact real missions. According to Dr. Emily Johnson, a lead software engineer at Boeing, we have implemented a series of redundancies and cross-check mechanisms within the software to ensure that any anomalies are caught and corrected promptly. This approach significantly reduces the risk of timing errors and mission-critical failures. On the communication front, NASA's expert team is working closely with Boeing to enhance the spacecraft's signal resilience. They are integrating advanced communication protocols and hardware upgrades that promise not only to prevent signal loss, but also to improve data integrity and real-time transmission capabilities. Mike Sanders, a senior communication systems engineer at NASA, shared, "We are employing the latest in robust signal processing and error correction techniques. Our goal is to create a communication channel that can withstand the harshest conditions of space, ensuring that the spacecraft remains connected with ground control at all times." The parachute deployment system is also receiving a critical makeover. Testing has been intensified, with additional focus on redundancy and reliability. NASA and Boeing have introduced rigorous environmental testing scenarios that mimic a wide range of potential deployment conditions, from high-altitude ejection tests to simulations of various atmospheric re-entry profiles. Steve Rogers, head of the parachute system development team at Boeing, explained, "Our parachute systems are now subject to some of the most stringent testing protocols ever devised. We're not only ensuring that they deploy, but that they do so reliably and consistently under all conceivable conditions. The safety of our astronauts depends on it." This multi-faceted approach, combining software integrity, communication robustness, and fail-safe parachute systems, showcases the dedication to overcoming these hurdles. By incorporating lessons learned from past missions and advancing technological practices, Boeing and NASA are taking significant strides to safeguard the Starliner's future missions, ensuring that the spacecraft not only meets, but exceeds stringent safety standards required for human space exploration. The implications for future missions if these warnings go unheeded are nothing short of dire. If the issues with the Boeing Starliner remain unresolved, we could face a cascade of failures that would echo throughout the entire space exploration community. First and foremost, astronaut safety would be at significant risk. The unaddressed software glitches could lead to mission-critical errors, jeopardizing the lives of those on board. Imagine a scenario where a timing error or a communication blackout happens during a critical mission phase, such as docking with the International Space Station. The inability to control or communicate with the spacecraft could result in catastrophic collisions, or worse, complete mission failure. Such an event could be a devastating blow to human spaceflight, shaking the confidence of astronauts and the agencies that support them. Beyond the immediate risks to astronaut safety, there would be broader ramifications for space travel. A high-profile failure of the Boeing Starliner could lead to a loss of public and governmental support for space missions. Funding for future projects could be slashed, and the momentum we've gained in recent years toward greater human presence in space could be severely hindered. The stakes are not just technical, but also political and financial. The Commercial Crew Program was designed to reignite American spaceflight capabilities, and a failure here could set these goals back by years, if not decades. Furthermore, the ripple effects could extend to international collaborations. Space missions today are often joint ventures involving multiple countries and space agencies. A failure to address these warnings could erode trust in partnerships, complicating future collaborative efforts. Other nations might reconsider their involvement with NASA or Boeing, opting instead to develop their own independent capabilities. This would fracture the cooperative spirit essential for ambitious projects like lunar bases or manned missions to Mars. The commercial spaceflight industry, too, would not be immune. Private companies looking to enter or expand their roles in space travel would face increased scrutiny and regulatory hurdles. Investors might become wary, slowing the influx of much-needed capital into innovative space technologies. In the worst-case scenario, unheeded warnings could spell the end for not just one spacecraft, but could undermine the entire framework of human space exploration as we know it. Therefore, it's imperative that every warning is taken seriously, and every potential flaw is rigorously examined and corrected. Only through diligent work and unwavering commitment to safety can we ensure that the Boeing Starliner and future spacecraft achieve their missions without incident, paving the way for a new era of safe and reliable space travel. In summary, the Boeing Starliner's journey has been one of ambition, innovation, and daunting challenges. We've explored the critical software issues that exposed vulnerabilities, the communication breakdowns that threatened mission control, and the parachute deployment concerns that could jeopardize safe landings. Each of these technical hurdles draws unsettling parallels to the harrowing experience of Apollo 13, serving as stark reminders of the ever-present risks in space exploration. From rigorous software testing to strengthening communication systems and enhancing parachute reliability, the steps being taken to address these problems are comprehensive and vital. But what does the future hold for the Boeing Starliner? Will NASA and Boeing's efforts be enough to avert another spaceflight disaster? As we look to the stars, we're left contemplating the delicate balance between technological advancement and the inherent dangers of exploring the unknown. What lessons can we truly learn from history to ensure that the bold steps we take forward do not repeat the missteps of the past? The answers to these questions will define the next chapter in human spaceflight, and only time will tell whether the Boeing Starliner will soar as a triumph or become a cautionary tale etched in the annals of space exploration. Stay tuned as we continue to follow this critical story and unravel the mysteries that lie beyond our planet. Don't forget to hit that like button, subscribe to our channel, and ring the notification bell so you never miss an update on the thrilling and ever-evolving frontier of space exploration.